vector stores and the retrieval pipeline, the emergency flight manual. Today, we're covering vector stores and the retrieval pipeline, one of the most important days for the AWS Generative AI Developer Professional Exam. If you truly understand this, RAG questions stop feeling mysterious and start feeling mechanical. Let's lock it into your brain with a story you won't forget. Hash the memory story. The emergency flight manual. Imagine a major airline. They have a 10,000-page emergency operations manual. Pilots ask questions like, what do we do if smoke appears in the cockpit? What if the landing gear doesn't deploy? Who authorizes fuel dumping mid-flight? If the AI guesses, people die. So this AI is not allowed to improvise. It must retrieve exact procedures every time. This system is built using Titan embeddings, a vector store, a retrieval pipeline, grounded answers only. That's what you're learning today. Part 1. What a vector store really is. A vector store is a special kind of database. It stores three things together. The text chunks, their embeddings, the metadata, like source, version, category, permissions. Its job is simple but critical. When someone asks a question, which pieces of text are closest in meaning? This is semantic search, not keyword search. The vector store doesn't care about exact words. It cares about meaning. Part 2, Vector Stores. The exam expects you to know, for AWS exams, some answers are correct and some are traps. AWS-friendly and important options. Amazon OpenSearch serverless with the vector engine. Bedrock knowledge bases, fully managed RAG DynamoDB with vector indexing. Valid external options, Pinecone Weaviate Milvus FAS. Wrong answers the exam wants to trick you with S3 by itself, relational databases without vector indexing, plain keyword search, let the LLM search documents directly. If there's no vector search, it's the wrong answer. Part 3, the retrieval pipeline, the core flow. This pipeline is exam gold. In simple human language, it works like this. A user asks a question. The question is converted into an embedding using Titan embeddings v2. That embedding is compared against vectors in the vector store. The system retrieves the top K most similar chunks. Metadata filters are applied. The chunks in question are sent to the LLM. The LLM answers using retrieved facts. If you can explain this flow clearly, you pass a huge part of the exam. Part 4, the airline manual step by step. Now let's see this pipeline in action. First, the emergency manual is prepared. It's chunked into small, meaningful sections. Each chunk is embedded with Titan embeddings v2. Each chunk stores metadata, aircraft type, chapter, severity level. Now the pilot asks, smoke detected during takeoff. What is the procedure? The system embeds the question. That embedding is compared to all stored vectors. The closest matches are smoke in cockpit during takeoff, fire warning procedures. Those chunks score highest in similarity. Tap Part 5, Top K retrieval, very important. The system retrieves only the top K chunks, usually 3 to 5. Why not 50? Because too many chunks. Increase cost, create noisy context. Confuse the model, increase hallucination risk. This is an exam rule to remember. More context does not mean better answers. Top K should be small and focused. Part 6, metadata filtering. Metadata filtering is what keeps answers correct and secure. In the airline system, filters might say, aircraft type must be A320, manual must be emergency procedures, region must be international. This prevents the model from retrieving the wrong checklist. If the exam says, ensure users only see documents they're authorized for, the correct answer is metadata filtering in the vector store. Not prompting, not guardrails, filtering. Part 7, similarity search types you must recognize. Most systems use cosine similarity. It compares vector direction, meaning not magnitude. AWS also loves hybrid search. Hybrid search combines keyword search, vector similarity. This works especially well for large enterprise document sets, and OpenSearch Serverless supports it directly. Part 8, where people fail, exam traps. Here's where candidates lose marks. Letting the LLM search documents itself, storing embeddings in S3 without search, retrieving entire documents instead of chunks, increasing temperature to improve accuracy. All of these are wrong. Correct answers always involve embeddings, vector stores, top K retrieval, metadata filtering. Part 9, choosing the right vector store. Use Bedrock knowledge bases when you want managed RAG, Minimal setup, AWS native services, fast exam-safe answers. Use OpenSearch serverless when you need large-scale advanced filtering, enterprise security, custom pipelines. The exam likes both, but especially Bedrock knowledge bases for simplicity. Part 10, the golden exam sentence. If you remember one sentence, remember this. Accuracy in RAG depends more on retrieval quality than on the LLM itself. AWS loves this idea. Final memory lock. Vector store means semantic search. Tighten embeddings v2 mean meaning, not keywords. Retrieval pipeline means embed, search, top K, filter, answer. Too many chunks cause hallucination. Metadata filters ensure correctness and security. And one last check to seal it. If a system gives wrong answers even with a strong model, the first thing you fix is retrieval, not the LLM. That's vector stores and the retrieval pipeline, permanently locked in.